All right. Okay, it's recording now. All right, let's get started with day 3 of CAM. We'll basically mainly doing 2x1s today. There's like a certain nuance to doing 2x1s, and I'm basically explaining that, and we'll go into the actual CAM for it. Right. So uh, let's do next slide. Okay. So far we've canned like plates, right? It's like aluminum plates. We haven't done polycarb, but polycarb is like the same thing as aluminum plates. And so basically it's cut on this large like rectangular piece of stock that we buy, right? And we buy like 4 foot by 4 foot sheets. Um, and then the thing is that in your camp, so like on the left here, I have a picture of a gearbox plate with like the yellow bounding box. That's like the minimum size of stuff I need to cut that out, and the X and Y axes, right? So the origin point is where the two arrows start. And basically, your cam says if you start at that origin point and you have at least this much stock left, you can cut this plate out, right? And what we do is we just go on our actual CNC and we set our origin point somewhere on this 48 by 40 sheet, for example, and just cut it. So like um, this sheet could be, so like that gearbox, I could set the origin there and I could cut it out and you can see that gearbox would be cut. There wouldn't be any problems. I could set it there and it would still work. So I can set it in various different places and it would still work. Um, okay, all right. And then, so you can like set it anywhere and you can still have it work. The origin point, where exactly it is relative to the 48 by 40 sheet isn't super critical, right? The problem with 2x1s is that, and when I say 2x1s, I'm referring to all aluminum extrusions that we use. So like 1x1s, 2x1s, 2x2s. We haven't really used 3x3s, but those are also something that we could use. But basically, they all have a predefined shape, right? It's 2 by 1 inches, and you can't change that. Like it's not the 48 by 40 sheet, and you can have whatever you want. And so all your holes for like the hole pattern, they need to be exactly half an inch from the edge, right? And if they're not exactly half an inch, you have the case on the left where you try to assemble it, but your holes are like offset because your origin point wasn't correct when you cammed it or whatever, right? And now you can't attach it because your gusset isn't made for that offset. So basically, the whole point of this is that the 2x1, it's super critical that from this edge, this hole is half an inch away. Whereas with your aluminum plates, like the holes on my gearbox plate could be anywhere from this whole 48 by 40 sheet, doesn't matter as long as the plate itself can be cut properly. So the solution for that problem is that we basically have our CNC set up in a way that every single time I go to cut a 2x1, I place that 2x1 in this exact same spot. Like if I measured that spot from the wall in the room, it would always be the same exact place, right? And what we do is we tell our CNC, hey, remember, this is where my 2x1 is going to go. And based on that, it'll always cut it the same exact way. And the way it works is, so you can see the X and Y axis here, that's our CNC, right? So that's our CNC. We'll always start at the origin point there. And then if we can find a way to always place our 2x1s at that exact corner, we can always get the correct 2x1 like cut out. And the reason is our cam says, hey, CNC, from the origin point, move half an inch down and then drill a hole, right? And because our 2x1 is always at that exact same spot, we will always move half an inch down and cut a hole that's in the right exact spot. So any questions so far? Like this is super important to how 2x1s work in CAM. No questions? Okay. In that case, we'll get moving. Right. So what we have for that solution is what we call a 2x1 jig. And I just have the definition for a jig there in case you don't know. It's like anything that holds a piece of work or guides the tools that operate, right? But basically, this 2x1 jig, so there's a GIF here from a different like team, but it works the same way. So all you have here is a 2x1, and you see this like bottom edge. So I'm going to use the pointer, and you can see this bottom like edge that he's sliding the 2x1 against. That edge is going to be fixed there permanently. So that edge cannot move, right? And then you'll see when you see the screw over here at the very right edge. I'll wait for the GIF to restart and you can see that screw again. So where my pointer is, there will be a screw there. So right there, there's that screw. And so that basically defines a corner. And so every single time he cuts that 2x1, he's going to push it to that edge. And he's going to use these red things that are clamps to hold the 2x1 in place. And this way, every single time he cuts a 2x1, it will always start at this point. And he can say on the CNC, hey, always start the 2x1 at this point, and it'll cut everything correctly. So there's this beautiful picture here of me and it's the modeling from the CNC. But the important portion here is that this is what our jig looks like on our actual Laguna CNC. And so you can see that similar kind of edge here. That's the straight edge that we aligned a 2x1 with. There's a screw here behind my finger that's where the 2x1 stops. And you can't see in this picture, but behind this 1x1, if you've ever been near the CNC, you've seen those like golden nuts kind of things. Basically, it's a line of screws. And if you tighten those screws, you can clamp the 2x1 in place. So it works the same way as the GIF I showed you guys in the previous slide. It's just a little bit different. And this was made by like, I think the seniors in 2018. But it works the same way. You get a 2x1, you slide it across so that it hits the screw and this edge, and then you tighten it with those clamps and those screws, and you can start machining. And you will always have this corner lined up in the correct place. So do you guys have any questions in this setup? No questions? It all makes sense to you guys? Yes, no? Yes? Okay. All right.
Yes.
Okay. All right. So this is like another visual to how the CNC looks. So this is looking at CNC. I tried to draw on it as well as I could, but basically, the left portion of the CNC, the big portion here in red, that's where we cut out all our plates and things, right? So that's like reserved for plates and things. But then this right side where this blue small rectangle is, that's where our 2x1 jig is located. Um, Hold up. There are people entering the meeting that I need to give me 1 second. All right. Okay. So basically this right side here is the 2x1 jig. And so what it means is when in your cam, we'll do this in our actual cam, but when you set the origin point, remember we set our origin point for our plates so that the X and Y are going into our part, right? And the Z is always up, but the X and Y go into our part. Now what happens with the 2x1 jig is because the corner is on the left side, this 2x1 jig origin is on the left side, our X axis actually points away from our 2x1. So that's a subtle difference in terms of doing the setup for 2x1s. That's different. And it's also important because otherwise your CNC will start cutting in the wrong area. So that's another thing to remember. Anyone have any confusion about this part of it? Nope. Okay. Okay, yeah, so that's like part one of today's cam thing, and then I'll switch over to Inventor. Share screen. So if you guys have any questions, chat or unmute and speak right now. Otherwise, we'll go over to Inventor. All right, so I'm an Inventor. I'm going to open a 2x1. So let me do this. Okay, so this is inside the MVRT 2020 off season folder. So I'll just find this West Coast Drivetrain 2x1. And so we'll start as we always do. We'll go into cam, setup, and then it'll do the setup thing. So we'll cut out the top portion here first of our 2x1. And so remember, it was on the left side. So I'm going to click this corner here. Right. So if I look from here, it is on the far away side. It's on the left corner on top. And then you can see the axes are messed up right now. So I'm going to go in model orientation, select 0Y, and then we'll select the Z to be upwards. And the Y and the X are correct right now. So remember, the X has to point away from the 2x1 in this case because the jig is to the right side and like our origin on the left. And then again, you have to do the no additional stock thing on this tab over here. Hit OK. So there's our setup. Now to actually cut out or like drill these holes on top, what we do is right click, create from template, and then you do select template. And so again, in the parts library in the CNC folder, there's all these folders. If you click on 2x1 and you select drill, this is the drilling template for 2x1s. Hit open, double click that, and then you just select the hole you want to drill, and it'll auto select all the other holes with the same diameter. And you can see that every single operation, it drills through only one side, 2x1. So like it doesn't drill all the way through. Reason being, we don't have drill bits that are that long, and also it will hit the jig itself.
I have a question.
Uh-huh.
Wait, why is the x-axis pointing like outwards again?
So why is it pointing outwards? All right, so that has to do with, let's go back to, so it has to do with this, right? So basically, oh, what happened? Okay, let me present again. All right, you can see the presentation, right?
Yeah.
Okay, so if you look under looking at CNC, right, the x-axis is positive when you go towards the left. So when you go towards the red stuff, that's called plate stuff there. But our origin for our jig is actually on the left side. So if I wanted to cut anything in my 2x1, I would move towards the right, right? Um, but if you see, look at the X arrow over here. Let me do pointer again. This arrow, that's pointing to the left. But if I want to do anything on my 2x1, I have to move to the right. So what it means is I would move negative direction, basically. All it means is the X is pointing that way,
Okay.
basically. Yeah.
All right. Got it.
Yeah, if you were doing a plate, like a gearbox plate, and you set your origin on this left corner here, you would do the same exact thing. But we usually do the right top corner for plates, and so that's why it's different from doing plates.
So I have a question for you guys. Why do we have only this? Why do we have only the holes on this face, on the face that Jathan has? Why is it only selecting those holes? Why aren't we selecting any of the other holes?
Like these ones here.
Because like when you clamp it to like the sides of it, you won't really have access. Like this, the CNC can't like tilt side. It can't rotate 90 degrees just to cut the holes. So it can only cut up and down. And you're not gonna get the bottom ones because, well, yeah, like Justin said, we don't have a drill bit long enough, and you could damage like the bottom of the CNC.
Yeah, I meant the side holes, the ones on the side face.
Yeah.
It's just we can't just get access to them because the CNC can't tilt.
Yeah, there's no 90-degree Allen key equivalent of a drill bit, so you can't drill 90 degrees into something. So that's why we just do one side at a time, right? So here we just do the drill, we hit OK, and that is good to go, right? And it's the same drill setup as like the plates where you have chip breaking, so it does like a woodpecker action instead of going all the way in at once. And then so the next thing, so just like Ritvik asked you guys right now, right? We can't drill the holes on the side. So then how do we cam it? So this is where so far for plates, we've been doing a single setup, right? So you create your origin point there and you do all your actions there and you're done, you're good to go. But the thing with 2x1s is what you do in real life is you would clamp it, you drill the holes, you unclamp it, and then you twist it 90 degrees and then do the other set of holes. So what you have to do in cam is you have to create a new setup. So what we'll do is we can right click or click on the top setup button, new setup, and this will be a second setup. So this would have its own origin point that's different from our first setup, right? And so what we do is we just tilt our 2x1 90 degrees. So it's now 90 degrees this way, right? And we're gonna do the same thing, top left corner, and we're gonna change the axes so that the Z points up and the Y points along the 2x1. And now you see the X is going inside. We don't want that, so we'll do flip Y and it'll change accordingly. And we want to do no additional stock here, right? Hit OK. And so here's our second setup. So these are two different setups. They have two different origin points and they'll have their own operations. It's like two different folders, right? And so now I can right click, create from template, drill, and we'll do the same exact thing here. We'll select this hole and that will select all of the other corresponding holes. And these are 5/32 rivet holes. So it like the tool works, 0.159, it works here. Hit OK. Now there's also these 4 holes here for the gearbox, for drivetrain gearbox. So I'll do another right click, create from template, drill. We'll select these ones. And this time, as you can see, the tool is smaller than my actual hole size. I have to go back here, click on tool, MVRT tool library, find the 257 drill, select, and now it's good to go. We hit OK, and there's those holes. So now you can see this setup has all these holes. So now we're going to do the bearing holes, right? And so this is where things get, again, a little bit different from what we do in plates. So what you would do is do a 4mm end mill contour. Now, the reason for using the 4mm instead of the 6mm is because 2x1s are fairly easy to cut because they're always a 16th or 8th inch in thickness, and the stresses are just far lower. So like you can use a 4mm, and you don't need to use the big 6mm end mill. So we do the 4mm end mill, but if you notice, it's a contour for these bearing holes. And so we're not going to do the adaptive thing with the plates where it like cuts away every single thing inside of that circle. Now I'll show you guys the reason for it. But do you guys remember why we didn't do that with plates? What was the reason?
The puck would go flying.
Yes.
Like the
So
middle
you can,
portion?
yeah. So you see here, it cuts out the circular path, but it would leave something in the middle. And we can actually see that if you simulate it and you turn on stock. If it cuts out that like outer outline of the bearing hole, but it leaves this little piece in the middle. And once it finishes that hole, if it will speed up a little bit more, right, it will leave this bit of stuff like that hanging circle in there. And so we need to get rid of that, right? Now the thing is, with a plate that's sitting on top of the CNC, that puck can go nowhere except up. It just flies out of the CNC the moment it's loose, right? But with 2x1s, you see this top surface is actually an inch like above the bottom. And so that puck can like just fall straight down. And gravity is pretty strong, thankfully. So whenever we do that contour thing here, the puck just falls straight down instead of flying out. So that's the reason why we do a contour on 2x1s instead of adaptive, because the puck just falls down. Now, during the season, there have been a few times where the puck decides it wants to go on a trip and it just starts flying instead of going down. But generally, it's not like as bad as it would be on a plate because it's lower energy. So it's not, it works. So it's not like this is dangerous or anything. We're not being sketched. This works. Mr. Shinta has approved this as well. So it's safe to do. All right. So you guys, any questions so far on 2x1 cam? Feel free to chat or.
Are you gonna do like the third template right now?
The-
Because there was like
yeah, yeah, we'll do the third one as well.
Okay.
But anything so far? Nope. Okay. So we do this contour. Now the second thing, so we did, what did we do so far, right? If you want to make this 2x1, we did these holes on the top. We did these holes on the side and the bearing holes. Now we go back to these holes, right? The ones on, oh, let me select this, on this edge. We haven't done these, right? Now, if you look, these holes are just a hole pattern, right? It's half an inch from the edge, and it's the same as this side. Like it's fully symmetrical. So I could create a third setup on this side instead and do all these holes. Or what I could also do is just reuse this cam that I did on the actual CNC. I just have to flip the 2x1. So this is something that's actually advantageous about 2x1s is if they're symmetrical, I can just flip this 180 degrees and run the same exact operation without having to cam a second operation. So this will just work again. So I don't need to cam anything else. Now for the bearing holes, if you guys remember, West Coast drivetrains have a drop center, which means the center is a little bit lower than the sides. You can see that clearly, like the circle bearing hole, right? It's closer to the top than it is to the bottom, right? So if you look here in this contour, our origin point is on the left side, right? And if you look at the bearing holes, the bearing hole is closer to the right than it is to the left edge, right? Now, if I were to flip this 2x1, 180 degrees, that changes because it's not symmetrical. And this time the bearing hole is closer to the left edge than it is to the right edge. So this is where you would have to create a third setup because it is asymmetrical. So what I would do is new setup, and you pick that origin point over there, and you change the axes. So Z is up, and our Y is along the 2x1, and the X points away, so we have to flip the Y, and we want to do no additional stock. Hit OK. There's our third setup, and now we can do our contour here. So contour, pick all of our bearing holes, and if there were any other holes that were bigger than half an inch in diameter, hit OK. And there is that. I would also have to drill these gearbox holes because those are also asymmetrical. So let's do that as well. And then with the 2x1 jig, right? So if you remember, the reason why we always drill holes first on our aluminum plates or polycarbonate plates is because it can otherwise leave, right? If you just do the contour, the final shape, it'll just fly out. The thing with 2x1s is it's inside a jig, so it's already been clamped in place. So you could do the contour first and 2x1 will stay in place. So it doesn't matter if you do the holes first or if you do the contour first. With 2x1s, you have the flexibility to do either one first. Doesn't matter. And then tool here will change to 257. MBRT2 library, 257, select, hit OK. Now I know that these holes that are not the gearbox holes are symmetrical on either side, so I could just reuse that operation in that case. Let's see, there is a chat. Okay. All right, so we're almost done, right? Now, if you remember, 2x1s don't come in exact lengths, right? So like this 2x1 measured what? It is 24 inches in length. We don't get exactly 24-inch long 2x1s. We get like 2x1s that are 6 feet long, and we have to cut them down to the right size. So there are multiple ways to do this. First way is on the mill. It's a lot faster to cut a 2x1 to like the right length. So a lot of times what we do is just say, hey, I'll give it to Ritvik or Aditya and be like, here's a 2x1 that's like 4 foot long, cut it to 24 inches. And they'll just do that. And I can just do all my holes here and I'll be done. Now, if you don't do that, if you don't ask someone on the mill to do it, alternatively, what you can do is inside one of your setups, right? You can right click, create from template, parting. And parting just means you separate the 2x1 that you need from the rest of the additional access material. So you double click on the 2D contour. And then here, if you press Alt, you can select a single edge. So I'll select just this end edge over here, right? And I'll hit OK. And so what it will do is it will only cut along that like last part. So if this was a 4 foot long 2x1, we just cut away at this point, and it would basically cut half of the 2x1, and I would flip it over 180 degrees, cut the other half, and this 2x1 would be complete. And it would be 24 inches long. So that's what the third template operation is. That one is not like you can, it's kind of optional. You can do it on the mill. If you know how to use the mill, have someone else do it, or you could do it on the CNC. Either way, it works. In an in-person case, would you prefer using the mill or using the CNC to cut the 2x1s? So in an in-person case, the mill is faster. Like if you have someone that's experienced in the mill, it is much faster to do it on there than to do on the CNC. But there are times when people on the mill are busy with other things that are more important. So in that case, you can just switch to CNC, and you don't have to stop someone else that's working on the mill with something to do your 2x1. So you guys have any questions with this 2x1 cam?
For the third setup, couldn't you rotate it horizontally, like in this direction, on 180 degrees as well, so then you don't have to create a new setup?
Can't I rotate? Well, so this setup here, right, is cutting this on this face. If I just rotate it horizontally.
And then flip it as well, like both.
Oh, and then flip it?
180.
So, okay. So that's where actually you're assuming that your 2x1 is already 24 inches long, right? Because imagine, so basically it's like, if this is my base 2x1, or this is not a good color to see. Okay, this is my base 2x1, right? This is like 6 foot long, and I only want part of it. So I align this part, this edge, to my 2x1 jig, and I do all my operations here. But if I only want this bit, I don't want this extra bit. If I flip it, you can't fit the 2x1 anymore on your CNC. So that's why we have to do the second setup. But if you did have a 2x1 that was exactly 24 inches, like perfectly 24 inches on the mill or something, you could do that. The second reason why we usually don't do that is also because when you're on the CNC, the 2x1, like it's easy to see in CAD, but when you're on the actual CNC and you have a blank 2x1, it's hard to see what's 180 degrees this way and what's flipping over. And when you have like 20 2x1s to make, it can get confusing really quickly, like which way you flipped it. And so that's why usually it's just simpler to do it this way, because camming takes like 2 seconds extra. But if you mess things up, you have to redo the entire 2x1. So that's also another thing to keep in mind.
Is there a reason why we do parting last instead of like doing it first, or?
Is there a reason? So part of it is that you can, well, basically parting, like if you have a really small piece of 2x1, like only 6 inches long or something, right? You don't have that much surface area to grip it with, and so it can move around a little bit more. But if you have like a 4 foot long 2x1, you can grip it super well because of all these points to grip it on. So that's one reason. Second reason is when you part on the CNC, it's not like it's a super flush straight cut like you cut it with the katana or something, right? Like the cut can have like problems in it, and so like it might be like 24 and a 16th inch or something. So parting isn't the best, like the finest thing CNC can do. That's part of it, but yeah.
That's why you use the mill to get that nice finish.
Yes, the mill is a lot better at the parting thing. Although you can't do it on CNC. I've done it. I've also done some other sketchy things with the 201, but we don't worry about
It's
that.
almost like the guy that was milling it was kind of useless at that time.
Oh, you guys any questions on this? No? Okay, so going back to our presentation, there's a final thing. So remember in our previous cam things, I was talking about how in cam, like when you go on any operation, this first tab has information about like the speed and how fast is your end mill or drill running, right? Stuff like that. So these speeds are like part of the G code that you export when you post process it. But the thing is that the Laguna CNC, the controller, the thing that has like the brain in it, process your G code, it actually overwrites those speeds. So it doesn't matter if your cam says like 18,000 RPM or 800 RPM. The Laguna controller is going to be like, no, I don't care what you say in your G code or in your cam. I'm going to overwrite those speeds. And it asks the user when you're actually like machining to enter speeds manually. And so what that means is all the speeds that you set in here, these are irrelevant if you're machining on the Laguna. So for that reason, the speeds that we have in our templates, these are all made for the Omeo. So like this 18,000 RPM is based on the Omeo, not the Laguna. And if you were on the Laguna, you would use a different speed. And the reason why you have different speeds for the two CNCs is because the Laguna has like a bigger motor. And so it's got a little bit more torque. And so you change up your speeds. And so we actually on the Laguna CNC have a speed chart, which is based off of this spreadsheet. Basically, it has multiple scenarios. So like if you're cutting aluminum with a 1/4 inch end mill or an 1/8 inch, right? Use these feeds, and feed is basically how fast it's moving, and spindle frequency is how fast it's rotating. The frequency is in hertz, so that's why it's not 18,000 RPM, it's 300 hertz. But basically, there's this chart on the CNC. So if you're on the Laguna, you look, oh, I'm going to doing a contour on 1/4 inch aluminum with this end mill. Okay, I'll set these speeds. So, and these speeds are like safe levels, so you can run this speed no problem. During the season, I've like bumped this up to 550 or this up to 300 to like go a little bit faster. Or you can slow it down for like a dull end mill. But beyond that, these are basically speeds you would use if you were working on the Laguna. If you're on the Omeo, these speeds in inventor do matter, and these will decide how fast the CNC moves. So that's just a quick thing to note about the speeds and things.
Also, just to bring this up, if you were to ever work in the shop and you guys were working with the CNC and you guys change some of the settings around and you hear it really like screeching noise and Mr. Shinta is telling you to stop, like stop it immediately, because then you know that something is like going wrong. Like even if it doesn't sound that bad and Mr. Shinta is telling you to stop, you need to listen immediately, because that happens to be that, you know, we don't always listen to him, and there's kind of, you know, he gets kind of annoyed and pissed about that, and like rightfully so. So just make sure to listen to him whenever you're in the machine shop. This is maybe his rant part 3000 that you're going to be hearing, but yeah.
Yeah, machining has a lot of audible clues to like when things are about to go wrong. So that's why like having an ear open, even if you have headphones on, you can still keep an ear open. And if you hear anything that's like doesn't sound too good, always have like a finger on the pause button or the stop button. You can stop it, investigate it. Sometimes it's just like it's a dull end mill, it's making a lot of noise. But other times it could actually be something that's slightly dangerous or like the CNC is about to break. So it's good to watch out for audible clues. You guys have any other questions on 2x1 cam? And you would post process this just like you would normal thing. Generally, I would make like subfolders, so like vertical 2x1, horizontal 2x1, so that I can keep track of all the different setups. But other than that, it's the same thing for post processing. If you guys don't have questions, what I'll actually do is go back to, you guys remember when we did nesting last time? I forgot how to like change the stock size, right? So I finally remember how to do that, or I visited my video on the website and figured it out. So basically, when you create a nest, oh no, this thing, okay. Basically, when you create a nest, right, there's this button over here called Process Material Library. And if you click on that and you click on packaging, you can change sizes here. So you can make this like 40 and it will change it to 40. And you can also, yeah, so you can just change the sizes there. You can do everything here. So you can add more stuff, right? And you can change the packaging here so you can make a different one for like the Omi or something, right? And stuff like that. So you can use this to change how big the rectangle is. And when you do source, I'll just do a little thing because why not? We'll select the plate. Yes, hit OK. Once it loads, and there it is. We'll create our nest study. All right, hit OK. And so it will create our nest. And you can see this is what? This is 20 by 40, 20 by 30. That's the size that's at right now. I can go in Process Material Library in packaging. I can change this 20 by 30 to 30 by 30. Hit OK. And it will change this to 30. Oh, this was the wrong one. Never mind. I have to change the other one. Packaging, make this 40 by 30, for example. Hit OK. It will update it. Hopefully. Update. It is being weird. Packaging. Yeah, it should update. Don't know why it's not updating. It updated last time. Oh, you have to hit calculate again. I think that's why. Yeah, there we go. It's working now. Where is my nest? Okay, yeah, but you guys get the point, right? You can change the packaging size from here, right? Any questions on that? No?